So in today's lesson, we're going to be learning how to add, subtract, multiply, and divide complex numbers. So complex numbers are any number that's in the form a plus bi, where a is your real number and b is your imaginary number. So the I connected to the b is equal to the square root of -1. So that'll be helpful later. So with our first type of problem, we're going to be learning how to add these numbers. So let's use the example 3 plus 4i plus 5 plus 6i. So you can see they're in the form a plus bi, and you can only add, subtract, multiply, or divide. You could only add and subtract like numbers. So the 3 and the 5 are like numbers, so you're going to add those, and that equals 8. And then the 4i and 6i are like numbers, and you could add those, and it's 10i. So that's going to be your final answer. So it's super simple. For subtract, we could use the same numbers just to show you the difference. 3 plus 4i minus 5 plus 6i. So we'll use the same principle and do like numbers. So 3 minus 5 is -2. And then 4i minus 6i is -2i. And that's your final answer. So multiplying is a little bit different, but it's very similar to how you would normally FOIL out a problem. So again, let's use this example. 3 plus 4i times 5 plus 6i. And you could use whatever method you like to distribute. I personally like the rainbow method. So 3 times 5 is 15. 3 times 6i is 18i. 4i times 5 is 20i. And then 4i times 6i is 24i squared. So this I squared, if we remember earlier in the lesson, I said I just equals to the square root of a -1. When you add a square onto a square root, it cancels it out. So in this case, it would just leave the I. In another example, if you take the square root of 9, that equals 3, but if you square on top of that, that would equal 9 again. So it just cancels out. So in this case, I squared just equals -1. So it'd be 24 times -1. So then you could simplify your like terms. You have 38i, and then 15 minus 24, which is -9. And that is your final answer. So last but not least, we have dividing complex numbers. So if we use the same numbers as before, 3 plus 4i divided by 5 plus 6i. In this case, you want to use a method called taking the conjugate. And what that means is you're going to multiply by the denominator, the numbers in the denominator, but you just want to take the opposite of the sign. So in this case, it would be 5 minus 6i over 5 minus 6i. And this just equals 1, so you could multiply by these numbers, and it wouldn't even affect the problem. So just like before, you're going to multiply these numbers out. So 15 minus 18i, and then plus 20i, and then minus 24 times a -1, because you have the I squared. And then you're going to simplify your like terms. So you're going to have 2i, and then this is a positive 24, and then the 15 equals 39, so 39 plus 2i. And you're going to repeat this step on the denominator. So you're going to have 25 minus 30i 25 minus 30i. And then you're going to have a positive 30i. And that's what taking the conjugate does. It basically cancels out the I in the denominator because you don't want a square root in the denominator. You would normally rationalize it, and this is what it's doing. And then 6i times negative 6i, which is a negative 36i squared, which is just negative 1. So these cancel out. Then you have 25 plus 36, which equals 61. And then you're going to put your two pieces together. So you have the 39 plus 2i over 61. But you can't leave your fraction like this because it's not an a plus bi form. You have to separate your numbers. So you're going to have 39 over 61. And then the second part is 2i over 61. I'm just going to add that to the second part. 61. And that is the final answer.